Hello everyone, welcome to today's session where we'll be talking about a very important low-level design pattern in software industry, which is called the Singleton design pattern. So hi everyone, my name is Rajat Nagpure. I am a software engineer at Google and I have close to 4 years of experience. And let's get started. A Singleton design pattern. So what is a Singleton design pattern? So Singleton design pattern is a low level design pattern of a creational type. So what do I mean by creational type? So we have different kind of design patterns in low level design, which are creational design pattern, behavioral design pattern, and structural design pattern. So Singleton design pattern is a creational design pattern. What are creational design patterns? So creational design pattern essentially deals with the creation of a object in a design pattern. What do I mean by that? We'll talk about it later. Uh, let's get to the next point. So what is a singleton design pattern? So definition of singleton design pattern, what is it? Singleton design pattern is a design pattern which ensures only single instance of a class is created throughout the application's life. What do I mean by that? And that single instance should be accessible globally throughout the application. So only one instance created throughout app life cycle and globally accessible. Okay, so singleton design pattern ensures only one instance of a class is created, and that should be accessible globally throughout the application. uh, where do we need a singleton design pattern and why do we need it? So why do we need it? There are some examples where we use singleton design pattern, like logger, config manager, then we have db connection, and then we have thread pool, etc. Okay, so why do we need a why do we need to ensure only single instance is created for a logger? So in an application, we have a logger instance which essentially we call on it like, we want to output some log, we call a function or method inside a logger class, and it ensures that the log is the log is written in the log output file. So if we create multiple instances of a logger, then all of the logger, either they'll try to access the same log file or create a different log file. In both of the scenarios, the log will be log from application will be created, will be outputted into different application, or the different logger instance will try to access the log same instance of a log file. So that will create a problem for us, so that will create an inconsistency. So if we have different logger instances, uh, if if they are outputting different log file, that we don't want, because we want to ensure and we want to know the sequence of the control flow of an application. So for that purpose, that's not good. And for the other purpose, if other logger are not able to access the log file or open the log file, then only some few of the log will be outputted or logged into the log file, which is what we also don't want. So only single instance of a logger is created, which is that instance is accessible throughout the application, and only one single instance is created for the life of an application, to ensure consistency in the log. Other thing is configuration manager. What is configuration manager? Configuration manager is needed in an application to load all the static data of the application. So there is a config file which has all the static data required for the application to run properly for its life cycle. So what we do is configuration manager loads all the static data in one single object, and that single object will be accessible with that static data throughout the application. We don't need essentially multiple configuration object because it's a static data. And if we go on and create the instance of the configuration manager at each place, we need the static data, config file static data. Then we'll be creating multiple instance of the class, which will essentially uh, waste our memory, and we don't want that. So just one single instance of the config manager should be created, which should take care of all the, which should load all the static data, and it should be available for the whole application. So in this scenario also we need a singleton design pattern. Other examples are DB connection and thread pool. Thread pool also we just need one thread pool, so that we should so that here also a singleton design pattern is useful. DB connection, we don't want to open multiple DB connections in an application. It will use lot of, otherwise it will use lot of ports and memory essentially to maintain that connection. So it will create a lot of memory wastage if we go on creating multiple DB connections each time we want to perform a DB operation. In this scenario also we just need a single instance of a DB connection, and so singleton instance or singleton design pattern take care of that scenario also. uh, what so Let's go ahead, we'll talk about the code, how does it look. So if we'll come here, here we have a singleton design pattern. Here the name of the class is single thread. This is a singleton design pattern. So in this class what we are doing is like we are defining a class, a variable which has a private static instance of the class type itself. And then we have a private constructor. So why do we need a private constructor? Because so this private constructor and this variable won't be accessible from outside of this class. This things will only be accessible from inside of this class. Then how do we create instance of this class? So that comes to a public method which is get instance. So what is a get instance method? So every time in an application anyone needs the instance of this singleton class, it will call this get instance which is publicly accessible, and then this method will take care of creation and maintenance of this singleton object. What do I mean by that? So each time an application needs an instance of this thread of this class, it will call get instance. When it will call get instance, it will come inside the control flow, will come inside, it will check if the instance object is null. If the instance object is null, which is initially null when the application has been started, then it will go inside and call the private constructor to create an instance of this class. When the instance of this class is created, it will be assigned to the instance object or variable, and then later it will be returned. And so later it will be returned and also assigned to the private variable. So next time when an application calls this same get instance method, this time what is happening, this instance will already have the instance object populated. So next time when the control flow comes here, instance object won't be null because last time we instantiated instance with the this one instance, and so this time it won't go inside this if block and just directly return the instance object. We also have the Java C++ implementation of it. Here also we can see the private singleton variable which is static, and then private constructor defined here. Then we have a public class public method which is get instance, which will be called from multiple places. So only this get instance static function will be called from outside of the class. So whenever we want the instance of the singleton object, singleton class, we just call the get instance. So this time, this is the first time we are calling this. The control flow will come here. This is a static function, that's why we call this function without creating the instance of the object, but it ensures that an instance of this class is created and it assigned to the instance object. So next, first time when it comes here, it will check the instance is null pointer. It is in the first time, so it instance of variable will be assigned with the assigned with first the private constructor will be called, the instance will be created, and this instance will be assigned to the instance variable and then returned. Next time when this function will be called, and next time when this we are creating another pointer for the singleton variable, a get instance will be called, it will go to here. This time this instance have the instance variable assigned to it. So this time this if block won't be executed, directly instance class will be returned. So here we'll see the show message. Show message is essentially printing the address of both the instances. So if you'll see singleton instant address, which is which can be printed like this. So from both of the pointer singleton pointer, if we are trying to print the we are trying to call the this function, both of them should print and will print the same address, since both of the pointer are pointing to the same instance of the class, which is a single instance. So the address will be same for both of them. uh, there are few caveats here. Singleton object have different kind of implementation. So for a single thread application, it can have, this is little bit more. So single thread application have two kind of implementation, that is eager implementation and lazy implementation, that have multi-threaded uh, uh, implementation of a singleton class, which we can take up in the next class. So this is a brief introduction or brief thing about a singleton design pattern. So let's summarize what all we covered today. So singleton design pattern is a creational design pattern. uh, and what is the singleton design pattern? Singleton design pattern, okay, so singleton design pattern is a creational design pattern. What is singleton design pattern? It ensures only one instance of an class is created throughout the application lifecycle, and this instance should be globally accessible. And what are the applications to this design pattern? We have different applications, and where this design pattern is used, which are logger, configure manager, db connection, thread pool, etc. So I hope you liked the class, and if you have any questions, you can drop off the questions in the comment section, and we'll address those questions, and see you the next time. Thank you.